Solve x plus 2 over x squared minus 9 is greater than or equal to negative 4/5 graphically. Okay, so we're going to break this into two different graphs. So we'll have y equals x plus 2 over x squared minus 9. I'm going to go ahead and factor that into x minus 3, x plus 3. There, that's better. And then my other graph is y equals negative 4/5. Just going to be a horizontal line. Okay, so to graph this one, let's look at those characteristics we worked on in sections 1, 2, and 3. So we've got two asymptotes, one at positive 3, vertical asymptotes. One at positive 3 and one at negative 3. I've already got those in there from our denominator. And then for the numerator, that would give us an x-intercept at negative 2, correct? So let's throw an x-intercept at negative 2. That's because our numerator, if we set that equal to 0, equals negative 2. We can throw some zeros in for the x's. So 0 plus 2 over 0 squared minus 9 would give us a y-intercept at negative 2/9. So somewhere in here. Then horizontal asymptote, notice, is at y equals 0, and that's because the degree of the numerator is 1, the degree of the denominator is 2. If it's less on the top than the bottom, then our asymptote is at y equals 0. Okay, I'm not sure where my graph's going to go exactly unless I throw in some other points. So we might want to throw in a few other points and see where our graph leads us. But you can just trust me, and I'll go from the work I've already done on this previously so that it's not slowing us down. So basic look of our graph here is something like this. And you could verify that by plugging in some other points and seeing where they end up. Okay, so then we have the graph of the line y equals negative 4/5. So that would technically be right about here. I think I drew that in more at negative 1, but here I can use it just by using my, there we go, about right there, right? So we are looking at where our red graph is above our blue graph again, or equal to it. So we're looking at the pieces of graph from, here I'm going to do a highlighter, that might help. So where the red is above or equal to the blue, so that would be this piece right here, and this entire piece is above the blue. And then I feel like at some point, and maybe I just didn't draw this very well, but this graph is probably going to intersect that graph, and then there will be a piece, oops, didn't mean to move the blue one, then there will be a piece right here where this graph is above the blue as well. So I think the answer to this equation is going to be represented by those three highlighted pieces. Okay, now to figure out where the two important points are. So the points we're looking for would be right here and right here. We want to know where those intersection points are. So to find those, we've got to do some algebra. So even though we're solving this by graphing, we still need to do some algebra to find where those points are. So to do that, we're going to do our little solve by cross multiplying thing again. Cross multiply. So that will give us, let's see, 5 times x plus 2 is 5x plus 10. Maybe I should have taken the negative that direction. Nah, that's all right. We'll just do the negative the other way. I almost forgot we had a negative over here. We can't forget that. So let's do negative 4 times x squared minus 9. So that would give us negative 4x squared, and then negative 4 times negative 9 would be plus 36. So now all together, we can just move everything to one side. It gives us a quadratic to solve. So 4x squared plus 5x minus 26 equals 0. I suppose we should factor this thing. It's a little bit scary looking. Let's see. We need factors of 4 times 26 that add up to 5. So we could go ahead and do a factoring by grouping thing and experiment to find those numbers. Or you can trust me to save some time here. My factors that I wrote down for this problem are 4x plus 13 and x minus 2. Because right now our lesson isn't really about factoring ugly things like this. It's about using those factors to find the answers and to solve the inequality. So if you needed more help with this factoring step later, please let me know. Okay, so now at this point we have two answers to our problem by the zero product property. We take 4x plus 13 equals 0, so x equals negative 13 over 4. So that would be what, about 3.25, because 4 goes into 13 3 times with 1 left over. So negative 3.25, so I'm assuming that that would be a good representation of that point right there at negative 3.25, right? And then our other factor, x minus 2 equals 0, gives us an x-intercept, not an x-intercept, sorry, a solution at 2. So I really didn't show where this graph crossed properly. It should be more like, it's just my graph is a little bit off. So this graph should be more going through a point, so it's more about right there instead. Anyway, that's what those two answers are telling us, is that those are where those intersection points are, where the red graph is crossing through the blue graph. Okay, so with that in mind, now we can write our intervals for where the red graph is above the blue graph. So we've got this piece over here on the left, which is going to go from negative infinity to where x equals negative 13 fourths. Or you could just use negative 3.25. That doesn't really matter. Now, at this point, are we going to use a bracket or a parenthesis? Do we have an asymptote, or do we just have an intersection point? Are we trying to do equal to or just greater than? So it is greater than or equal to. It's not an asymptote at that point. It's just a point where the two graphs intersect. So that point should be included because of the equal to. Right? Now let's look at the next piece of our graph. So this piece, the red part, is below the blue part, so we're going to ignore that, right? And this piece up here, the red part is above the blue graph and on the left, on the right side of this asymptote at negative 3, until it gets to that point where they intersect at 2. So on the left side of this piece would be negative 3 for the asymptote, but it doesn't include the asymptote, so I have to do a parenthesis. And then that piece, red piece above the blue piece, would end at 2, and the reason we know it ends at 2 is because we solved that earlier and got this x equals 2. So again, that's another point where the two graphs cross. So that is not where there's an asymptote where it can't exist. It's just a point where they intersect. So since we want to know where it's also equal to, that can be a bracket. Then our very last piece is the last piece of our graph, which is on the right side of our asymptote at x equals 3. So that's going to start at the asymptote 3 and then go to infinity to the right. This should be the solution set for where the red graph is above the blue graph. Questions on